Thank you, ma'am. Thank you for accepting our invitation.
It's my pleasure, Dr. Kumarasan.
Thank you. Thank you, ma'am. Jeffrey, sir, are you there? Anya, ma'am?
Yes, sir, I'm here.
Yeah, good afternoon, ma'am. How are you?
I'm doing well, thank you.
Jeffrey, sir, shall we start or yet to join, sir, some others?
Sir, we can start, sir.
Okay. Good afternoon, everyone. I welcome you for the resource person and participant for this wonderful webinar. The learning should be a joy and full excitement. It is life's greatest adventure. It is an illustrated excursion in the minds of the noble and learned as quoted by Taylor and Caldwell. Here we are conducting a research-related webinar organized by Neurological Physiotherapy Unit, Department of Physiotherapy, St. John's Medical College and Hospital, Bangalore. I thank our beloved director, Reverend Father Jesdas Rajamanikam, our Associate Director of College, Reverend Father Charles Davis, and our Vice Dean Ma'am for their encouragement and constant support. We are conducting the webinar. I welcome Mrs. Yashoda Bhargava, Senior Research Fellow, Department of Biology, BITS Pilani, Goa campus. I welcome you, ma'am, accepting our invitation to be a resource person in this webinar. I am sure this webinar 100% helpful for your future endeavor, whoever attending, the participant, faculty, and other undergraduate students. I welcome all the participants to this webinar, and I thank Ananya ma'am, Neurological Physiotherapy, to arrange this resource person, and Jeffrey sir to organizing this wonderful webinar. Thank you once again. I welcome you, the resource person, once again. I would like to call upon Ananya ma'am to introduce the speaker and welcome for the speaker. Thank you everyone.
Thank you, sir.
So it's my honor to welcome you, Dr. Yashoda. She's completed her Masters in Public Health from University of New York, UK, and is currently pursuing her PhD in BITS Pilani, Goa campus. And she's been recipient of several awards such as Young Developer Award in Samsung Research and Development Bangalore, among many other awards. We are thankful that she's taken the time and accepted our invitation for today's webinar. It's a beautiful talk. I've heard this talk in the international conference that was held at Goa. And I think it gives a very, very good perspective on how to understand your raw data and how even small errors that you make while understanding or interpreting your raw data can change the results of how you analyze your study or how you understand your study. So, Dr. Yashoda, I think you can take over.
Sure. Okay. Thank you, Dr. Ananya. Thank you, Dr. Kumarasan, for giving me this opportunity. I literally have goosebumps. And thank you so much for making such a wonderful poster. I really love it. So I appreciate the efforts of the entire team in making this possible. And I hope that I will be useful for you in this webinar. So can I share my screen? Dr. Ananya, can I share my screen?
Yes, please go ahead.
Okay.
My name is not visible.
It will come. Okay.
Yeah. Yes.
Sorry, son.
Okay.
Network is not that great here, so.
It's okay. I hope everyone can see the screen. Hello.
Yes, ma'am.
Okay.
Yes, we can.
Okay.
Yes, ma'am.
So I'll talk about the title. The title is The Dirty But Important Task of Engaging with Raw Data in Times of Hyper-Automation, Demonstration of Subtle Errors in Data Science. So this title has a history which you will obviously get clarity on as we talk about this, because when I was doing my own research, these are exactly the same errors that I had made, and that made me think that this work is really dirty, but it is important, and from that the idea had come. So a little bit of history of this talk. I think Dr. Ananya has already mentioned that this talk was given by me in the conference that was held recently. So basically at BITS Pilani Goa campus, we had a conference, international conference on computational neuroscience and bilingualism on 26th and 27th of April. My mentor, Professor Vicky Butts, gave me this opportunity to talk about some research in this conference, and because of this I thought about what to talk about, and hence I could think of this idea, and based on my research experiments and experience I chose the topic on data handling. So at this juncture I think it is absolutely valuable to thank my mentor and my professor Vicky Butts, who has always given me opportunities to explore the horizons of science. Now going forward, how did this work originate? Any research that starts up always has some roots. So what were the roots of this work? You might not be knowing, but I am working on use of virtual reality technology for assessment of dementia. Well, not exactly dementia, but the earlier stages of dementia, the cognitive impairment and the mild cognitive impairment. So basically I was doing a lot of experiments with the VR headset and collecting a lot of data. We in fact completed 2 pilot studies in young people in BITS Pilani, and another in Bangalore, Anna Swami Mudaliar Hospital, among 53 adults aged 60 years and above. So as I was dabbling with the real world data of these people, data was coming up and I was analyzing. So slowly I was thinking how to analyze it, and then because we were collecting data, it was getting stored in the Firebase. In simple term, you can think of it as a database. So next I was beginning to collate the data for analysis. That is me in my lab. So basically the data we were collecting directly on the Firebase, and then I was supposed to analyze that data on my workstation. But as I was progressing in this, I began to notice some inconsistencies. So noticing the inconsistencies itself was a serendipity, but because you're looking with the data with such sharp eyes, even though the data is getting collected automated through the VR, there is no reason you should not be skeptic about it. So I started noticing some inconsistencies, and that sort of made me think over that what to do going forward. So what if I study all these inconsistencies in primary data handling? And hence then I started thinking in that direction, because I was handling the raw data, even though it was coming from the VR headset and the games, everything was automated, made by our pipeline, but even then there were certain things which were inconsistent. So the question just came into my mind, what if I study all these errors in handling raw data? That is the primary data, because I was collecting and my team was collecting the primary data directly from the participants. And this was a fascinating opportunity to demonstrate using real world data that how errors can seep into our system and then aggravate over the period of time, and literally cause havoc on the analysis and results. And at the same time, because I was thinking of it in the scientific term, I was thinking, of course many scientists have approached this problem, many scientists have approached this problem before me. I am not the first one. However, when I read the existing discourses and papers, they were highly theoretical. Now, so they were telling us lessons and mistakes in a conceptual manner, but the wider context was missing. Because, for example, when you know that p values are important, or you should not do p hacking or data dredging, these as concepts, but all of us work in real world with real data. So that bridge between the theoretical knowledge, context and the applied knowledge seemed very missing in the traditional discourses. So then I thought that, okay, let me take a bunch of all the examples that I have experienced and try to give a contextual nature to this data handling of the raw data. And that is how, one step led to another, and then this talk came up, and which I believe is very useful also for the budding researchers to know all this. So I hope the gist of the talk is clear to everyone. In between, if you face that something is not clear, you can always raise your hand and we can clear your doubts there and then. You don't need to wait till the end. Okay, so hoping that we are clear with the starting point, now I will move ahead. So what did I do? Basically, I took all the real world examples from my research and took the context, and I wanted to think about data science. So these days, you know all the technologies and methods that appear. So for example, in Python or in R or in SPSS or MATLAB or Stata, whatever tool you are using, I'm sure all of you are aware of the methods. But knowledge of methods is not sufficient. We should inculcate data science thinking. Now the traditional discourses were telling about, do this, do that, but they were not incorporating how to think when you are dealing with the data. So through this talk and through this work, I wanted to foster data science thinking, because methodology follows your thinking. The tool that you are using has to follow your thinking. So thinking always precedes the methods, and that is why I wanted to, just talk about these simple things. So basically, I studied most of the errors in my work and came up with these sort of broad categories. So basically, in this talk, I will talk about data handling, theme points on data copy, data verification, missing data imputation, process checks, sharing data responsibly, subject interview, and score creation. And this entire talk is absolutely examples based. So, and if you're confused as to why I'm talking about this, even previous, big data project failure study has shown that big projects fail because we are very bad at data management and data integration. Now, I would like to say that we are not bad. I mean, that would be a negative way to look at it. We still have a long way to trying to understand data, as it is, not through it's just a number. No, data always has a story, and we should be engaged more in the data going forward. So for the people who are skeptic about the idea of this talk, this evidence clearly shows that data management and data integrations are one of the prominent reasons that big data projects fail. So now we will jump to thematic analysis. So first of all, I want to discuss about data verification. Please excuse the aeroplane that has just passed over my building. Okay, so data copy and verification. So, in clinical science, I'm sure you are all doing clinical work. There is always instances when you're copying data, be it patient questionnaire or interviews. You're always, if you're doing a large scale study, you're always copying that data into your Excel or whatever tool you are using to analyze it. Okay, so data copy error is a very, very common error. Now, most of the time, sometimes the numbers can be in decimals. Okay, so as you can see in this screen, when I obtained the data from the VR headset, these were the actual values, A equal to B and C. So these were all stored in Firebase. Now Firebase is not an Excel format, it's not a CSV format. So I had to copy the data from the Firebase to the Excel. Now some of you would say that we could have directly created Excel from the Firebase, but the structure was so that I had to copy. So then I really did not like the idea of copying the entire decimal. I'm being human about it, because human wants to minimize the efforts. So what I did was, initially I was just rounding it off to the 2 significant digits and copying it. But these values, like as you can see, A, B and C, these were being used later in computing a composite score during this formula. So when I computed this from the rounded off digits, it was 61.11, but when I computed from 65.74, there was a difference of 4.63. So the question is that this difference can be meaningful or it cannot be meaningful depending on the context. Again, we should cultivate after this seminar the habit of never looking at data without context. Context is always very, very important. So in the context of the VR game that I was developing, it turns out that that difference was huge, because it was about the cognitive performance of the participant. So this is just one example in which data copy or error in data copy can lead to some future errors. And if in your study you are using some decimal numbers which you think will be used in future computation, the best strategy is to use the digits as it is. Even if you are not using it in future computation, I think it's a good scientific practice to copy it as it is. In scientific papers or publications, you can probably round them off, but because if that primary database is lost, then your values are lost, and that becomes a problem. So for example, what if my formula, that is a into 11 b into c, that itself was wrong, and I had stored only the final values, then I could not backtrack to the original values and get the right results. So that was one of the lessons that I noticed an inconsistency, and that is why data verification and data copy are very, very important. Now the second thing that I observed was observer drift. Now observer drift is a very technical concept. I did not know this term when it was happening in my work. It was like I experienced it first, and then I wanted to find out if there is any scientific term or a technical term for it, and it turned out it was called as observer drift. So if a study involves 40-50 participants, this was from our young pilot, which involved around 93 participants. So copying from Firebase to Excel was a tedious operation. But when you start a task, you are attentive, you are fully concentrated. But as you go over the in the middle of the task, what is to be done. Sometimes we drift apart, we don't pay as much attention. So that's called as observer drift, and that can lead to errors in data copy. So that exactly happened. My original value was from the Firebase was 12.348. That was the primary database. My value was supposed to be 12.348, and I was supposed to copy that same value in the Excel. But it so happened that I copied the value adjacent to the Firebase data. And all this while I was not aware that this huge difference has come up. So I had not noticed this until I started analyzing the data. So because I had copied from the original source to the Excel source, I just wanted to see what was the correlation and how these two values related. So then I plotted a scatter plot diagram. And here you can see that technically these values should not be very apart, because value A and value B, but if you look at the x-axis of value A, it's almost in hundreds, whereas value B, it's in less than even 30. So that red dot that you see, it was an outlier, and I was thinking that what's wrong here? It should not happen. So basically it was an unexpected behavior that, but at this point of time, I did not know that I had copied wrongly. I thought that maybe that value is like that. Even that time I did not know that something wrong has happened. And that's when I told myself that I need to backtrack and go back to the source. And when I went back to the source, I realized that I had copied the adjacent value. And these things can become clear only sometimes, when only you plot. So always plot your data. Even if it's a single variable, plot your data. And if you're looking at bivariate analysis, always plot your data. That is, in technical terms, it's called as exploratory data analysis, so that you can see that the values are in the expected range, in the expected domain. And if they are not, do not discard them by default. Study them. Study the outliers. Study the values that are not falling as per your expectation, and then decide what is to be done. So I did that, and I changed it's to the original value. So that was a data copy error, but it was entirely tweaking my story. And when I changed it, now you can see that value A, the x-axis, and value B, y-axis, they are almost in the same range. But in this, I not only corrected the original error, now I even had an insight. And the insight was that for values beyond a certain point, after 15, there were two patterns that I was noticing. So you see, a simple operation called as data copy, if done non-attentively, can lead to errors. And inattention is very natural, it is very normal. And that is why data verification is important. So even if after 50 forms you have entered all the data, and I know it can be a lot of effort to fill that data into the Excel or into computers, but as good scientists, it is our duty and our responsibility to go back and verify. And if we are working in a team, probably we can distribute the roles of verification and data copy, because if the raw material is intact, our results will be reliable. But if something goes wrong here and it turns into garbage, then the entire story that we will be telling using our data analysis uh, can be really very problematic, especially if it relates to real world people and participants and patients. So I hope using these two examples, you have clarity on data copy. I will also share this PPT later so that you can review it in your free time. So now data verification. In data analysis term, data verification is considered always numerical. But in the course of my experiments, I realized that we don't talk about semantic verification, we don't talk about contextual verification. We should not look at data just as numbers. Data convey a meaning, a story about that person or a population. So if there is one thing that I want you to learn from this webinar, it is never look at data without context, because context always dictates better what it actually means. So for example, outlier verification, all of you must have come across outliers. But why is particular value an outlier? So for example, if you plot the weight of a animal and the weight of animals offspring, and the elephant will lie at the top right hand corner, but that does not mean it's an outlier. It just means it's an elephant which is supposed to have high mass and high weight. So outlier verification is one of the ways in which we verify, but sometimes we have to be cautious about whether to remove this outlier or not. There should be justification at each step. Just because it is an outlier is not a right reason to remove it. You should have a sound enough reason that okay, this is an outlier, these are its characteristics, and it is reasonable enough to remove it. So I will give you an example. In one of the games that we had made, memory game, our first pilot was in the young people. So for the young people, we had developed a score, okay, and then that score was hard coded. But in the old people, there was one parameter that was changing, because obviously for old people we have to give them more time to think over things and recall, because their cognitive speed may be less. But we forgot to change the formula accordingly, and our pilot in old and young people is finished, and we have no idea that there is something wrong in the formula. But again, then we are testing the app for our third pilot, and then it turns out we get a negative score for the old people, and that again leads us to backtrack that why we are getting a negative score. And it turns out that one of the parameters that was changed for young was not changed for the old people, and then we made the entire formula dynamic. So you see, without the context and semantic verification, we could not have come across this error. And that is why testing is also important. And for one person it is very difficult to do all these tasks, and that is why the advantage of team is that you can discuss and you can relegate the responsibilities so that the entire pipeline is sharp. So basically, if you don't verify the data, there are certain errors that can seep up into your system, like measurement error bias, confirmation bias, and self-reporting bias. But these biases are not the end in themselves. If there is bias, there is a way to rectify. So if you think that there is some measurement error bias, you can compare tools which are almost similar. If there is a confirmation bias, humans, we are not perfect basically, and so we should not beat ourselves for not being perfect, but we should be aware of how we are not perfect, where we can make mistakes. So most of the times it is very difficult to be an objective as a scientist, as a researcher, but that is something that we learn. So sometimes our confirmation bias can color the way we are looking at data, or our analysis and results. So we should always embrace contradictory evidence, even though if you don't like it, if you feel challenged, but science is always bigger than our own things, because our ultimate loyalty is towards science. So we should embrace contradictory evidence and use it to further strengthen our work and obviously refine our thinking. And when is self-reporting bias, I'm sure a lot of you on a regular basis talk to patients and participants, and if you sense that there is self-reporting bias in them, you can probe a little bit more to try to identify what exactly is happening here. So that is why data verification is important. So I hope by this time I'm able to convince you of the importance of data verification and data copy, and these two operations will not be the same again next time you go to your workstations and work on it. The third theme that came up was missing data imputation. So missing data is a very common occurrence in dealing with raw data and patient data and participants data, and my research was not an exception. However, there are three types of missing data most people do not know. So the three types are missing completely at random, missing at random, and missing not at random. These are very beautifully explained in Medical Statistics book by Martin Bland, who was a professor at University of York. I had the pleasure of meeting. So, and that's one book that I've been carrying for the rest of my life ever since I got interested in data. So it would be nice for you also to, it's a beautiful book, Medical Statistics by Martin Bland. And whenever I need to brush up my concepts, I go and look at that. Yes, someone raised the hand. Okay. So we will go forward. So basically, not all missing data needs to be thrown out of the window, because data is collected with so much of hard work and so much of effort, and in the participants also come, so their time is also there, your time is also there. It's very painful when you lose the data. So when you feel some data is missing, always try to identify how I can fulfill this missingness. Now, how to estimate that missing data or missing value will depend on the type of missing data. So again, most people just use average to impute the missing data, and they forget the context, but context is important, and I will show you how. So basically, when we were piloting the VR based games, because these were novel games, we could not base the performance only on one trial. We wanted our participants to play 3 trials, and based on the 3 trials data, we could actually estimate their overall score. But there were cases when we did not have the score of trial 3, or maybe it was lost, or maybe the person did not want to play. Something or the other happened, and we had trial 1 and trial 2 score, but we did not have trial 3 score. So in this situation, we have missing data, and we have data from trial 1 and trial 2. So, and these were situations which were very real and very painful also, because again, the effort and time of both the participants and the researcher. So a part of me said that I will use average of trial 1 and trial 2, what's the big deal? But then you should always question yourself that are these scores independent of trial number? So basically what it means is that the performance of person in trial 1, the performance of person in trial 2, is the performance in trial 2 independent of trial 1? Is the performance in trial 3 independent of trial 2? Which was not quite, because when you play a new game, initially you are amateur, you don't know, but in the first trial they have learned somewhat the rules of the game, and that will come into trial 2, and similarly in trial 3. So because these trial scores were not independent, average, they were not independent, so then how could I average, or how could I fulfill the missing data? How could I estimate the trial 3 data knowing the trial 1 and trial 2 data? So that was the big problem. So, but because these were dependent on each other, I had to drop the data. So average works if the trials are independent of each other. For example, if you take the blood sugar of the people for the 3 duration of times, and more or less it's the same, and and if the person has not gone out or had not had food or done any workout, so more or less it will be the same. So that time average is okay. But in this case, I had to drop the data because the trial 3 was not independent of trial 1 and 2. And this knowledge could only come when I looked at the context in which the person was playing the game. So again, context is extremely important for all these decisions. And a semantic and contextual understanding is key to decision making. So data science is about decision making. and wherever you are dealing with numbers, it is about decision making. So excessive focus on numbers as standalone entities can be very blinding. So whenever in your clinical setting some things like this happen, you should really think and discuss with your colleagues that what has really happened here, how do I go about this, how do I go about that, why the person has not shown up, and why their particular vitals are like this whereas previously it was like this. So, and sometimes we also need to talk to participants about that. So when you are trying to impute the missing data, do not use average as the by default strategy. Think over the context, and if the context shows that okay, average is fine, then you can be double sure of this strategy. And this short cartoon shows that the importance of context. The lady says is for a lot, and the guy says that it depends on the context. $4 is nothing, but 4 murders is a lot. So again, stressing the importance of context and numbers, that tells the complete story. Now another theme was score creation and average score. So because we were collecting, again going back to the VR games that we had developed, we were getting all the raw scores, and we wanted to make the cognitive profile of the person. So basically in that we would collect all the scores and make a complete score that identifies that particular person, which we would then compare against a traditional score. So there was a lot of scoring involved, and we had to connect these variables that we were getting into comprehensive and reasonable scores. So in one of our games, so basically in one of our VR games, I was getting 3 values: attention and planning score, navigation score, and processing speed from the games. So these also we had made, but using this now I wanted to make a complete cognitive score. So that was the task. So without thinking initially, I just added these scores, okay, and also I've written the results and I've interpreted it also. And then one fine day I'm just discussing with my colleague about these scores and literally flaunting that I have made these scores, and can you just comment on this? And then she points out that these 3 scores are in different dimensions. You add similar quantities, you cannot add quantities which are different. And at that point of time my head is literally spinning, and obviously I was flaunting the scores to her, and until she pointed out the formula error, and I had to change it. At that point of time, when you create something, obviously your pride is involved, your ego is involved, but again it is wise to discuss things and then resolve the issue. And then I realized, okay, a multiplication, because then you think score is directly proportional to A, to B, and to C, and obviously then multiplication seemed the right formula for this thing. So again, thinking about how to create scores, there's a lot of thinking that goes on, and again discussion is always very useful. So once I had these scores, I also wanted to verify statistically what is happening. And here you can see that the density function for the multiplicative score and additive score, and this sort of convinced me that okay, most people are here, so it has slightly better discriminating power than this thing. But conceptually also the multiplicative score made more sense, because the scores were directly proportional to, so the higher cognitive score is directly proportional to higher attention planning, higher navigation, and higher processing speed. So, and in my I think in my 1.5 years into my PhD, I realized, I actually learned this lesson from my colleague who is around 4 years younger to me, that you don't add dissimilar quantities, and that is something that will remain with me for long. But this slide was not there in the the conference that I had talked about. I think Ananya, I have added this new slide because this is something that I have just recently noticed. So I thought of updating my slide this bit because this thing is also important. So previously we talked about the wrong formula, but what if your formula is right? What kind of error can come then? When you get the right formula, you are very happy, but then something can happen. So in one of our VR games, because there is a game, it likes Beat Saber in the VR, I was computing the attention score in the one of the shopping carts game. I was computing the attention score. So the formula that I had used was correct items chosen divided by 1 plus incorrect items chosen. So very, very straightforward, simple formula. Score was conceptually correct. but there was a problem. Can anyone tell me what was the problem? So suppose the correct items chosen is 7. So in the best case, you choose 7 items as correct. So the performance, and the incorrect items is 0. So the attention score is 7. So what is the problem that you can see in this formula? Any guesses? Okay, so for me also I did not notice this error, but then because when we make the games we test the games also. So now in your notebooks, if you have notebooks close to you, if the incorrect item chosen is 1, so out of all the correct 7 items, the participant is able to finish the game. They still choose 7 items, but in the process of selecting those 7 items, 1 incorrect item is chosen. So the attention becomes how much? 7 divided by 2, 3.5. Now when I note, so now can you think what is something wrong with this formula? So your best performance is 7, your second best performance is 3.5. Is it justified? Anyone? So this I noticed when I was testing the app, because it is nowhere justified that your best performer is 7 and the second best performance is 3.5. So I knew that something needed to change. So then I did one thing. There were 7 cases and I chose all the incorrect items, and based on this particular formula, these were the scores. And there was something definitely wrong, because when someone comes first in class, for example, he or she gets 98%, and the second one gets 75%, it's highly unlikely. Most people get close to 90s. Okay, so this seemed unfair that a person is choosing only one single wrong item and the performance of attention is literally dropping 50%. That did not seem quite right, and that made me think. So this is the plot of the these scores you see on the screen: 7, 3.5, 2.33. So this is how my the curve looked like for the performance of the people. This is the best performance, and this is the second best performance, and so there is no one who lies here, and that did not seem the right things to penalize the person so much for just making one error, and the attention drops to 3.5. So I was obviously unhappy at this, because first of all, earlier I would not make the right formula, but then I learned how to make a right formula, but even then it was not perfect. So again there was an opportunity to learn, and what was there to learn? So I introduced a penalty factor x in the denominator. So earlier I was penalizing by 1, like total number of errors, that was the maximum penalty, but here I introduced a penalty factor. Most of the times we think that if we are wrong we'd know, but that doesn't really happen. Sometimes we can be really blind to things wrong in front of us, but only when we visit them again and again then only it is clear to us. So what I did was, now the second question was, okay, what would be the value of this penalty, how much I penalize these items? So for that obviously I had to do the experiment. So what was the experiment? So in the initial case the penalty was 1, so penalty is the x factor, okay, that is in the denominator. When it's 1, this is the curve. When it's 0.49, half, it's this. When it's 0.2, it is this, and 0.1. So basically the graph may not be clear numerically. So the question is that which one will you choose? So if I show you, if the new formula is correct items chosen divided by 1 plus the penalty factor, and here the penalty values are this, can you guess that which penalty should be in the formula so that the score is reasonable? Any guesses? And this is the new thing that I've added in this version of the talk. Any guesses? 0.1. Okay, Abhishek, thank you. Any reasons? So yeah, 0.1 is a good candidate, because as you know that the penalty, it seems reasonable that the best performer is 7 and second best performer is 6.36. So in fact in my experiment also I chose 0.1. But that's not the most important. The most important bit is thinking. How I thought about this entire process. And it's not that I looked at the formula and the thinking came to me. No. I looked at the formula and I tested the score for different cases, and then I looked at the distribution. Again, cultivating the scientific thinking. And before I made the formula, I did not know, but obviously before shipping the product into market, you always test. So in the testing duration, so most of the errors are seen in the testing duration, and that is why the effort that you take in collecting the data, at least 80% of the effort you should also spend in testing the data and discussing the data, because that's really important for science. So basically the old attention formula was this thing and the new was 0.1. Yes, Nishita.
The previous thing, the 0.2.
Yeah.
Why did you take that? Because 7 means if you take 0.1, the scoring was approximately 4.12. But when a person select all the wrong items, the person should get least score, isn't it?
Yeah.
So what was your reason for taking up 0.1? Because yes, I agree, definitely the person who selected one wrong item, 6.3 is the closest value. But if you look at the person who has done all 7 wrong, he or she should get the least score.
Yeah.
So why not 0.2?
Yes, that's a very good observation, Nishita. In fact, 4.12 is even more than the half of the score, 3.5%. And I have not thought about it, to be honest, but now you have triggered me into thinking. So I don't have an answer right now, but that is something that I'll truly think about, and that's a really great observation. And for your so there are 2 ways to look at these scores: the second best score and the worst score, right? So 6.36 is the second best score, but the worst score in that case is 4.12. Whereas in 0.2, the second worst score is 5.83 and the least score is 2.92. That again probably says that maybe this formula is not the right one with the penalty one. Maybe we need to find another formula, because if you look at 5.83, the person has done only one thing wrong. So losing almost 1.17 points doesn't seem justified. But the person has done everything wrong, even 4.12 doesn't look justified. Yeah, so probably then I'll need to rethink over the formula and go about it. So that's a fantastic observation. Thank you, Nishita.
Thank
you. Yeah. So basically, I think now Nishita has given me some homework to do. So I'll rethink over it. But for the sake of this talk, this penalty item actually helped me in looking at the scores in the context. I was able to solve one problem, that was the second best problems. But then obviously, as Nishita has pointed out, I also need to solve the problem of the worst case that I will be looking on it. Thank you so much, Nishita. Okay, now average scoring. So in the first part, we talked about how to create a score. In the second part, we would like to talk about average scoring. So how do you average the scores? So basically, there are situations in clinical research and even in human research. In our game, surely it was that we cannot base our scores on one trial. So there is always an average that needs to be taken. So, but because one score was a function of all the sub-scores, so basically if you look at the score formula, S equal to the function of all these sub-scores. So for the trial 1, I have these scores, S1, and the superscript indicates the trial number. Similarly for trial 2 and trial 3. Now how do I average these scores? Do I take the average of S1, S2, S3, the capitals? Okay, as shown in the green one. Or do I take the average of the individual items and feed it into the formula? So I hope the problem statement is clear. If a score is a composite score which is made up of sub-scores, and I have 3 trials in which I get 3 scores, S1, S2 and S3, and then if I have to compute the average, do I take the average from the bigger S's, S1, S2, S3, or do I take the average of the sub-scores and then feed it into the function and then get the formula? So that is another hurdle that I had faced in my research. So how to decide whether on context or test of difference of scores? So test of difference of scores means that you compute the average from both the formulas and see are they really different or not. but that is not sufficient, because even if two quantities numerically they have arrived from different ways, these are the same, but if the context does not justify that, it's not right. So should I follow the data or my instinct? That was the trouble I was facing at that point of time. So thankfully, again the same great statistician Martin Bland, he has created something called as the a plot which helps us to understand the difference of two types of formulas. So basically what I did was I subtracted score from average subscores from the average score and wanted to notice how different it is, you know and it turned out that the mean difference between these two type of average score was 0.75, and the limits of agreement was minus 0.42 and to 1.94. So these did not seem like much of a difference. I could have used either, but again you have to justify your choices with the context. So the context was very important, and in that I thought to myself, is it okay to take average of the sub scores, or should I just average the scores of each trial? And going back to our previous understanding that these trials were not independent of each other, and that was the huge context, and that led me to take the decision that the trial scores are not independent, so average of subscores is inaccurate indicator of unbiased total performance. And that is why I ended up looking at the other way of taking the averages. But the bottom line is that numerical similarity must not be the basis to check contextual accuracy. So even if they are aligned, you always have to justify the manner in which you are computing the averages. That is absolutely very important. Now, next theme I noticed was subject interview. When you are doing research, most of the people think research only as quantitative, qualitative, or mixed. But in my experience, the best research are those in which we collect primary data from participants, but we also talk to them. Now, I know sometimes it can be overwhelming for you as doctors to talk, to patients, because you're dealing with so much of them. But when you're dealing with it's as a part of research, subject interviews can be very important. So, if you look at this plot, I basically administered the digit substitution test to the participants, but I had a twist to that. On the second page, I again printed that digit substitution DSST, but this time I did not provide the key. So to half of the people, I told that there is a test on the second page, but the key is not provided. But to the other half of the people, I caught them off guard, and they had to do the second part of the test. So basically that was just a funny experiment. I just wanted to see the time difference without the reference key and with the reference key. And when I plot the difference, so the red is a priori not informed, so they were not informed that there is a second page test. So obviously by logic there the time taken will be more without reference key, whereas for those who were informed of the test, the time is less. But there are two things that are happening. So these people, like this red person, she was not informed about the test, but how on earth her time for the second test is much less than the first one? That numerically if you look at it, she may be the best performer, that she has taken the maximum difference from all the people who are red. But when we looked at the context, these things came. This red one was 33-year-old, she was uneducated. So basically in the first page she took around 500 seconds, but in the second she took around almost 200. So that is why her difference was less, not because she was the most intelligent one, but because of her unique situation. So if you discount this context, you will see, oh, she is the best performer, but that's not the case. Similarly, in this one, black one, she is a 25-year-old mathematics PhD student, and her time taken for the second page was more, even though she was told. But when I interviewed her, it turned out that she was a sort of person who likes to cross-check everything she has done, and because of that unique idiosyncrasy or quirk, she ended up spending more time. So even though there is a pattern over here, and even though you get the most beautiful and most convincing results, if you see outliers here and there, because you can see there are a lot of variation, so you should not discount the context. Always combine the context and subject interview. with your raw data, and that tells us the complete story. And that is a subject interview, I believe, provide us a very unique perception of the data that we are handling. Finally, process checks. So we have talked about data verification, data copy, missing data, scoring, average scores, and most recently subject interview. Now most of the times the errors are not clearly visible to us. Sometimes we can be so into it that we cannot see it, and that is why regular process checks are important, because these help in minimizing the systematic errors. Now random errors and systematic errors are different. Please excuse the aeroplane. So random errors and systematic errors are very, very different. Systematic errors, once they seep into your system, they will wreak havoc in your system. So for example, that rounding off digits, it would introduce systematic error if there is a score difference. Okay, so process checks, in software development, there is something called as making prototype versions, agile versions. So you make a version, you test it, and then you go on to the next one. So process checks can really help us in making much more robust data analysis pipelines. And generally, as scientists and even as human beings, sometimes we are guilty of checking only when something wrong happens, only when we get unexpected results. So for example, if the p-value is more than 0.05, we did not expect, then we are scratching that, okay, what is wrong. So as a practicing researcher, let us train ourselves to avoid such mindset, and this can only happen if at every step we literally vet what is happening under our eyes and then try to understand if there is any error or not. Finally, sharing data and findings responsibly. Because we collected so much of data from the participants, they always wanted to know how they performed and how was their performance, how it compared with others. And I had not planned on making this report. Yeah, because we were conducting a study in which we wanted to collect the data, but some of them were very interested to know how they had performed. So it was a responsibility to tell them that their scorecard on these things, and that is why I decided with my team that we will create something called as the cognitive score report, in which they will be de-identified. So basically their name and age, everything will not be there. They will be given a unique ID which they already knew, and we would create these findings. Now, because we were sharing this report with lay people on their request, we could not be so technical. So we have to tell in the language that they can understand. So this is just a snippet of the general scores which we showed to them after they played our Hammer Eye game and the navigation game, the 2 VR games. And the performance visualization, if you see, very simple plots were shown so that they could understand. As you can see, on the x-axis is trial 1, 2, 3. On the y-axis, there are certain formulas that we had created. And at the end, so this was a bigger report. I have cut it into 3 parts for you. And in the notes, we also explained that what was game 1, game 2, semantic memory and short-term memory. So sometimes our participants help us to become better researchers, and certainly in both our young pilot and in old pilot, we shared reports with all of them who wanted to know about it. And that also helped us to become much more like disciplined in our approach, because when we are taking their time and they're asking for it, it is our duty to tell them how they're performing. So basically the conclusion of the entire talk is that using these examples, hopefully I've been able to give context, and obviously you have also helped me think a lot more better on these things, and I'm definitely going to think about what Nishita has told me. The overall conclusion is that data are used, but data analysis as a technique is used in a very fast and loose term these days, and especially because most of the people are using data, attention is not given to the deeper things related to data, for example statistics, context, semantic verification, contextual verification. So next time whenever you are looking at data, I request you not to look them at just numbers. It's definitely a story that it is telling, and certain errors can seep into the system and really disturb it. So that is why this entire, all the examples that I have discussed with you, they were dirty. It was very dirty to have a look at it and find out an error and then correct it. So it's not something that we enjoy in a world of hyper automation, where everything you just feed the data and something black box does something and the results is spewed out. But if the garbage is entered into the system, the garbage will be out. And especially in primary data, when we are dealing with patient data, participant data, it is our scientific responsibility to handle it with care and engage with it deeply, because then only we can do justice to it. And data analysis is not just number crunching, it is involves both semantic and numerical engagement. And I hope I'm able to inculcate data science thinking in your minds over data analysis. The thinking is important because analysis follows thinking, and that is why it's extremely essential to prioritize data thinking. And it works really wonderful when you're doing real world projects with real people, and I'm sure St. John's provides great opportunities for all these kind of projects. So now it's a little experiment time for you guys. It's time to see what you have learned. So on this screen you will see a QR code. You can scan that code and let me know. I'll just open it for you. Can you scan the code? Please let me know.
Yes, ma'am.
Okay. So I'm going to open this experiment. Okay, so you can see my screen. Can you see my screen?
Yes, ma'am.
Okay, so assuming you have learned something in this talk, what aspect of data handling will you be mindful about going forward? So I would like to know from you. So you can enter your responses. If someone is not able to scan the QR code, you can just go to menti.com and use the code 87217080. Are you able to submit the responses? Anyone has submitted the response so that I can check? Anyone? Any error you are facing? Kindly give me a heads up. Yes, okay, copying the data, great. So that means this is working. So I would like to know aspect of data handling that you will be mindful about going forward in your training as a doctor, as a researcher. What you will be mindful of going forward.
I'm unable to scan, but I'll be mindful
Okay.
of the outliers.
Okay, you're not able to scan?
Yes. No, it's my problem. Some problem with my cell phone, so that's okay. But yeah, I would be cautious about the outliers.
Outliers. Okay, what exactly?
Okay, for instance, I'm more into qualitative research,
Okay.
and when we do interview, it's just a small example.
Mhm.
So when there was a question asked, what makes you be less physically active, or what? And the mother of the child said that because she's a girl, I'm concerned about her safety. And in that particular
Okay.
interview, there were only
Yes.
2 female,
Okay.
and 8 of them were boys. So when I did the verbatim analysis, the safety issue was not even representative.
okay.
But later when I checked, I realized that just because I didn't take equal number of male and female samples,
Yeah.
the most important component of safety was not addressed. So that is something that I'll be
Okay.
remembering.
That's
And what you
great.
said, definitely the outliers has to be analyzed. So that
Okay.
definitely I'll keep in mind.
Okay. Thank you, Nishita, for sharing this wonderful insight with all of us. So creating formulas, observer drift, copying the data, interview, data verification, data handling. Wonderful. So hoping you have learned something from this talk, and we will keep looking at it. I'll also show the final this thing. So now going forward, what do you see? Okay, so this activity we have completed. Now I've come. Yes, Christo, you want to say something? Okay, so I've come to the end of the talk, and I want to say that this is not just my effort. Whenever we do something or get something in our life, we are always standing on the shoulders of people who lie behind us, or we're always standing on the shoulders of our colleagues, our mentors. So it is very important to be always remember that whatever we get and achieve in our life, it's not our own making. There are people who have supported us, and that is why we should always acknowledge them. I'm really thankful to my professor, Professor Vicky Bus, who is a superb mentor and guide, who's always supported me in my own thinking and endeavors. My colleague, Soumya Tripathi, who challenges my thinking and makes me a better researcher. We work together. Obviously, all the participants and lab colleagues at BITS Goa and students of BITS Pilani who participated in our pilots and who work with us. I'm also very thankful to Dr. Kumarasan for giving me this opportunity to share what little I know with your students. And I'm immensely thankful to Dr. Ananya Rakesh Sharma.
Thank you, ma'am. Thank you so much.
I'm also thankful to Dr. Ananya for attending the conference and then talking about this talk with all of you and taking the initiative for this to be shared with all of you. And finally, these are the organizations I work with, and I'm eternally grateful to the leaders and stakeholders in these organizations who believe in our work and continue to support us. So really helpful and thankful to the people and organizations. Finally, thank you so much for your time and patience and for believing that this will be worth your time. And if you have any doubts going forward, you can directly write to me. I will always be happy to help you. Thank you so much. If there are any questions, I would be happy to answer. So I hope you have enjoyed this talk.
Sure, ma'am. Thank you, ma'am. Thank you so much.
Thank you, Dr. Kumarasan. So, are there any questions? Dr. Ananya, are you there?
Yes, I'm there.
Okay.
I think, Jeffrey, you can give the.
I hope it was okay. It was.
No, it was very nice.
Useful to students.
Yes, it was very useful, and I'm really glad you added new slides and we got to know more.
It's a never-ending process, right? You always find out something or the other. Yeah.
Yes.
What I realized with, and this is Nishchita here again, so what I realized with your presentation is that the amount of data that you have, 2 people can do their PhD just by analyzing your data. So such immense data you have, and I truly appreciate all the efforts that you're putting in. And dementia is my field of interest too. I work primarily with elderly. And if you need in future, please, we can collaborate and you can test these games. You can do the pilot study on our elderly patients here.
Sure. Thank you so much, Nishita. Thank you. Means a lot.
Yeah.
So I hope you have seen my email address. In future, if I can help you in any way, please do not hesitate to contact me. I'll stop presenting. So, Ananya, Dr. Ananya.
Yes, so we would thank you again so much for giving us this talk. And I had loved this talk even when I had come to the conference. I'm sure everybody enjoyed the conference a lot. I would like to invite Jeffrey. He would like to give the end note to you. Thank you.
Good evening, everyone. I hope you have found today's webinar both enlightening and engaging. On behalf of Neurophysiotherapy Unit, Department of Physiotherapy, I would like to extend sincere gratitude to all those who have contributed to making this event a success. Firstly, a big thank you to our esteemed speaker, Yashoda Bhargava, for sharing your valuable insights and expertise with us. Your presentation on raw data analysis were particularly thought-provoking and will undoubtedly inspire us in our future endeavors. Next, our heartfelt thanks to the organizing committee who worked tirelessly behind the scenes to ensure everything ran smoothly. from coordinating the technical aspects to managing registrations and promotions, and your education has been instrumental. We also extend our appreciation to all the participants who joined us. Your active participation through questions and discussions enriched the learning experience for everyone involved. Last but not the least, we acknowledge the support of the department whose generosity and belief in our mission made this webinar possible. As we conclude this session, let's carry forward the knowledge gained today and continue to foster meaningful discussions in our respective teams. Thank you once again, everyone who contributed to this webinar. We look forward to welcoming you to future events.
Okay.
Have a great evening.
You too.
Thank you.
Thank you, Jeffrey. Thank you, Dr. Ananya. Thank you, Dr. Kumarasan. Thank you, everyone. See you again. Bye-bye.
Thank you, ma'am. Thank you so much.
Thank you, sir. All the best to
Thank
all
you,
of you.
Yashoda.
Yeah, all the best to everyone in your research. Bye-bye.
Thank you, ma'am.
Thank you.